The cosmos holds secrets that defy everything you think you know. We are about to journey through 30 mind-bending space facts that will challenge your very perception of reality. You will discover why a day can last longer than a year, and how a single spoonful of a star could weigh more than an elephant. What if the footprints you leave behind could last for millions of years? What does the vast silence between stars truly sound like? By the end, you will see the universe not as a distant void, but as a place of profound and personal wonder. Are you ready to question the nature of your own existence? Our own planet feels like a constant, its rhythms of day and year locked in a familiar dance. But step outside our world, and that certainty shatters completely. Take Venus, a world that defies all logic with its relationship to time itself. A single day on Venus, the time it takes to spin once on its own axis, is a staggering 243 Earth days long. Now consider its year, the time it takes to complete one full journey around the Sun. That takes only 225 Earth days. This means a day on Venus is genuinely longer than its entire year. You could celebrate your next birthday twice before the sun there rose and set just once. This bizarre reality stems from two factors: its incredibly slow spin and its relatively close, fast orbit around the sun. And the strangeness does not stop there. Venus also spins in the opposite direction to almost every other planet in our solar system. From a hypothetical viewpoint high above the sun's north pole, you would see most planets, including Earth, rotating counterclockwise. Venus, however, spins clockwise. This is known as retrograde rotation. Scientists believe a colossal event in the solar system's violent early history is to blame, perhaps a titanic collision with another large object that literally sent Venus spinning backwards, while also slowing its rotation to the agonizing crawl we observe today. This world of contradictions, where a day outlasts a year and the sun rises in the west, serves as our first profound reminder that the universe operates on its own extraordinary terms. That same chaotic early solar system that left Venus spinning backwards may have also seeded our world with an essential ingredient for life, an ingredient now found in staggering abundance out among the stars. Drifting near the center of our Milky Way galaxy, 25,000 light-years from Earth, is a colossal cosmic cloud known as Sagittarius B2. This vast interstellar cloud, spanning an area larger than our entire solar system, holds a secret within its swirling dust and gas. It is a giant reservoir of alcohol. More specifically, astronomers have identified vast quantities of vinyl alcohol within its depths, a molecule that is a direct precursor to many complex organic compounds. The sheer volume is almost impossible to comprehend. This single cloud contains enough vinyl alcohol to create billions upon billions of liters of the substance. Yet this is not a cloud you could ever drink from. The environment is far too hostile, and the chemistry is fundamentally different from the alcohol in your glass. So what is the significance of this cosmic distillery? Vinyl alcohol is what scientists call a prebiotic molecule. It is one of the fundamental building blocks required to form the more complex amino acids and, eventually, the very structures of life itself. Finding it in such immense quantities in deep space tells us something profound. The raw materials for life are not unique to Earth. They are being forged in the vast chemical factories of interstellar space, scattered across the galaxy by stellar winds and the shockwaves of ancient supernova. This giant cloud of alcohol is a testament to the universe's inherent drive toward complexity. It suggests that the seeds of life, the basic organic ingredients, are a natural and widespread byproduct of cosmic evolution, waiting for the right conditions on the right world to spring into existence. While the ingredients for life swirl between the stars, a permanent monument to human courage already stands on another world. The footprints left by the Apollo astronauts on the lunar surface are not fading. They are, in fact, etched into the dust with a permanence we can scarcely imagine on Earth. Those iconic impressions, along with the tracks of the lunar rovers and the equipment they left behind, could remain perfectly undisturbed for millions of years. This incredible longevity is a direct result of the Moon's utterly alien environment. Our own planet is a world of constant change, sculpted by wind and rain and the relentless flow of water. These forces of erosion wipe surfaces clean, filling in footprints and burying artifacts over mere centuries. The Moon, however, has none of this. It is a world frozen in time. With no atmosphere to speak of, there is no wind to whisper across the plains and scatter the fine lunar soil. There is no weather, no rain to dissolve and reshape the landscape. The only force that slowly, imperceptibly alters the surface is the constant rain of tiny micrometeorites, a gentle sandblasting on a timescale of eons. This means the evidence of our first tentative steps beyond our home planet is not a temporary mark. It is a silent, enduring museum exhibit resting in the sea of tranquility. Those footprints are more than just shapes in the dirt. They are a testament to a moment when humanity reached across the cosmic void and touched another world. They are a message to the far future, a declaration that we were here and we dared to venture into the great darkness. That same cosmic silence preserving our lunar footprints also allows us to hear the echoes of stellar cataclysms, events that forge objects of almost impossible density. A neutron star represents the final, furious crush of gravity. When a massive star many times larger than our Sun exhausts its fuel, it no longer has the outward pressure to support its own immense weight. Its core collapses in a fraction of a second, triggering a supernova explosion that blasts the star's outer layers into space. What remains is a city-sized object, perhaps only 12 miles across, but containing more mass than our entire Sun. This creates a density so extreme it defies all earthly analogy. Picture a single sugar cube. Now imagine that tiny cube of material, but it is not made of sugar. It is a fragment of a neutron star. That one sugar cube-sized piece would weigh not grams or kilograms, but approximately 1 billion tons here on Earth. To put that into a truly staggering perspective, that is roughly the combined weight of every single human being on the planet, all 7.5 billion of us, compressed into a space you could balance on a teaspoon. The physics behind this is a direct result of gravity's ultimate victory. The collapse is so violent and complete that it overcomes the fundamental forces that usually keep atoms apart. Electrons are literally crushed into protons, transforming them into neutrons. The entire star becomes a seething, super-dense ball of these subatomic particles, packed together shoulder to shoulder with almost no empty space. A neutron star is essentially a single, giant atomic nucleus, a cosmic artifact where the rules of everyday physics are rewritten by the sheer, overwhelming power of gravity. Floating in the cosmic crucible of intense heat and pressure, some worlds are forged into jewels of unimaginable scale. 40 light-years away, orbiting a star in the constellation of Cancer, lies a planet that defies earthly geology. Known as 55 Cancri, this exoplanet is a super-Earth, a world with a radius about twice that of our own, but with a mass nearly 8 times greater. That incredible density is the first clue to its astonishing nature. Scientists believe this world formed from a nebula exceptionally rich in carbon. While Earth is built primarily from silicon and oxygen, giving us a rocky mantle and a metallic core, 55 Cancri is a carbon world. Under the immense pressures deep within its interior, that carbon has been compressed and crystallized. likely transforming a significant portion of the planet into a massive, solid diamond. The sheer value of such an object is a meaningless concept, a treasure trove so vast it would eclipse all the wealth on our entire planet 1 trillion times over. Yet this diamond world is no serene, glittering orb. Its existence is one of cosmic violence. It orbits so close to its parent star that a full year, one complete trip around, takes a mere 18 hours. This proximity locks the planet in a gravitational embrace, with one hemisphere perpetually facing the star, much like our moon always shows the same face to Earth. This creates an environment of terrifying extremes. The day side, bathed in constant, scorching stellar radiation, is thought to be a global ocean of molten lava, glowing with temperatures hot enough to melt iron. The night side, forever turned away, might be just as alien, possibly a solid, frozen landscape. This creates a world of stark contrasts, a diamond core wrapped in a shell of seething fire, a testament to the universe's ability to create both breathtaking beauty and unimaginable fury in the same place. That diamond world, forged from cosmic extremes, is ultimately just a tiny speck orbiting its own star. This relationship of a minuscule planet to a dominant star is a pattern repeated right here in our own cosmic neighborhood, but on a scale so vast it is almost incomprehensible. Our Sun alone contains 99.86% of all the mass in our entire solar system. Every single thing we know and see, from the giant Jupiter to the rings of Saturn, from our own Earth to the most distant icy comets, all of it combined makes up a paltry 0.14% of the whole. This means if you could place everything in our solar system onto a cosmic scale, the Sun would be a colossal, gleaming weight, and every planet, moon, and asteroid together would amount to little more than a few specks of dust on the other side. This overwhelming dominance is the anchor of our existence. The Sun's immense gravity is the invisible hand that sculpts the solar system, dictating the paths of every world. It is the force that keeps Earth in its stable, life-giving orbit, and it is the same force that flings comets from the outer darkness on their long, elliptical journeys inward. We live within the Sun's realm, governed entirely by its power. Without that gravitational embrace, every planet would simply drift off into the silent, empty void, untethered and lost. This fact redefines our place in the cosmos. We are not merely inhabitants of a planet, we are citizens of a star's domain, living in the thin, scattered leftovers of its creation. That overwhelming dominance of the Sun is felt not through sound, but through an immense and unbroken quiet. The cosmos is a place of profound and absolute silence. Here on Earth, sound is a constant companion, a vibration traveling through the air, water, and solid ground, but space is a near-perfect vacuum, an emptiness so complete that it lacks the molecules needed to carry these vibrations. Without atoms to bump into each other and transmit the energy, a sound wave simply cannot exist. This means the most cataclysmic events in the universe occur in utter stillness. A star does not roar as it explodes into a supernova, two black holes colliding, releasing more energy than all the stars in the galaxy combined, do so without a single whisper. The terrifying violence of cosmic events plays out like a silent film of unimaginable scale. If you were floating in the void near a dying star, you would witness a spectacle of light and radiation that would blind you, but your ears would register nothing. The silence would be as absolute as the darkness between the stars. This is why astronauts on spacewalks experience such an eerie quiet. They are surrounded by the breathtaking vista of their home planet, but the only sounds they hear are those conducted through the vibrations of their own spacesuits and the internal systems of their spacecraft. The universe outside their helmet is mute. This eternal hush forces us to reconsider what it means to experience the cosmos. We are visual creatures in an auditory void. observers of a grand and violent ballet performed in perfect, infinite silence. Our sun's immense gravity dictates the rhythm of worlds, but in the case of its closest planetary companion, that rhythm becomes a bizarre and lopsided dance. Mercury, the tiny, sun-scorched innermost planet, has a day that defies all our earthly logic. A single rotation of Mercury, the time it takes to spin once on its own axis, takes 59 Earth days. But that is not the full story of a Mercurian day, because it orbits the Sun so quickly, completing a revolution in just 88 Earth days. A strange celestial synchrony occurs. The planet rotates 3 times on its axis for every 2 full orbits it makes around the Sun. This precise gravitational lockstep is known as a 3-to-2 spin-orbit resonance. The result of this complex dance is that if you were standing on the surface of Mercury, the time from one sunrise to the next, a single-day night cycle, would last a staggering 176 Earth days. You would experience a single continuous day that is longer than 2 full calendar years on Earth, followed by a night of equal, terrifying length. This leads to the most extreme temperature swings in the entire solar system. During that endless day, with the Sun hanging almost motionless in the black sky, surface temperatures soar to 800 degrees Fahrenheit, hot enough to melt lead. Then, as the world slowly turns and the Sun finally sets, the temperature plummets during the months-long night. Without any significant atmosphere to trap the heat, the surface radiates all its warmth into the void, plunging to nearly 300 degrees below zero. The same patch of ground transitions from a blazing furnace to a cryogenic deep freeze, all within a single, slow spin of this strange, resonant world. That profound silence of space is a canvas for a scale so immense it challenges our very ability to comprehend. The number of stars in the observable universe is so staggeringly large that even the most ancient and vast collections on Earth pale in comparison. All the grains of sand on every beach, in every desert, and beneath every ocean on our entire planet amount to a number we can barely grasp, yet the cosmos holds more. Astronomers estimate there are roughly 100 billion stars in our Milky Way galaxy alone. That is a 1 followed by 11 zeros, a number so large it already feels abstract. Now lift your gaze beyond our galactic island. The current best estimates suggest there are at least 100 billion galaxies in the observable universe, each a colossal city of stars in its own right. Some are small dwarf galaxies, while others are giants holding trillions of stars. When you multiply these unimaginable figures together, the total number of stars soars to a figure that is almost certainly greater than every single grain of sand on Earth. Think of the most expansive beach you have ever seen or can picture, with sand stretching to the horizon, every tiny speck in that vast landscape. Now imagine counting every beach, every dune in the Sahara, every hidden grain on the ocean floor. The universe, in its infinite grandeur, contains more suns than all those grains combined. This is not just a large number, it is a fundamental reordering of perspective. Our world, for all its beauty and complexity, is physically insignificant in this cosmic census, yet within this overwhelming vastness, we are the part of the universe that has become conscious, able to look up and attempt to count its own impossible abundance. This principle of a silent, ancient cosmos gives our telescopes a unique and almost magical power, the ability to see into the past. Every time we gaze at a distant star, we are not seeing it as it is in this moment, but as it was when the light now reaching our eyes began its long journey across the void. This is the concept of look-back time, and the Hubble Space Telescope has mastered it like no other instrument. When Hubble peers into the deepest, darkest patches of sky, areas that seem utterly empty to other telescopes, it is not just collecting light. It is gathering ancient photons that have been traveling for eons. The most profound example of this is the Hubble Deep Field. By focusing its powerful lens on a patch of darkness no larger than a grain of sand held at arm's length, Hubble collected light for over 100 consecutive hours. The result was not an empty blackness, but a stunning image teeming with thousands of galaxies, each a fuzzy, glowing island of stars. The light from the most distant of these galaxies had been traveling for over 13 billion years to reach us. We are not seeing them as mature, structured spirals. We are witnessing them in their cosmic infancy, as they appeared when the universe itself was young, just a few 100 million years after the Big Bang. These are the building blocks of the modern universe, captured in a state of furious formation. That single, humble image transformed a pinpoint of nothing into a window to the dawn of time, revealing a universe far more crowded and active than we ever dreamed, and proving that by looking out into the deepest space, we are also looking back into the deepest past. That same ancient light reveals the slow, majestic death of a giant. For at least 400 years, a colossal vortex has churned in the atmosphere of Jupiter, a storm so vast it could swallow our entire planet with room to spare. This is the Great Red Spot, a permanent hurricane of unimaginable scale. It is an anticyclone, a high-pressure storm where winds scream at speeds exceeding 400 miles per hour, rotating in a counterclockwise direction that has remained locked for centuries. When it was first reliably observed in the 1600s, it was estimated to be over 25,000 miles across, wide enough to fit 3 Earths side by side. But this titan is not what it once was. Recent observations from telescopes and spacecraft tell a different story, a tale of slow and steady decline. The storm is shrinking. Measurements show its width has diminished by more than half since the 19th century, and the rate of this contraction appears to be accelerating. It is not just getting smaller, it is also changing shape, slowly transforming from a wide oval into something more circular. Scientists are watching this transformation with a mixture of fascination and curiosity. What is fueling this ancient storm's slow demise? The exact mechanisms remain a mystery. It could be interacting with other, smaller storms, which act like cosmic buzzsaws, disrupting its flow and stealing its energy. Or perhaps internal turbulence is causing it to gradually dissipate, its furious winds slowly bleeding momentum into the chaotic Jovian atmosphere. The Great Red Spot has been a constant feature of our solar system for longer than our modern civilization has existed, a landmark in the sky. Its potential disappearance would be the end of an era, a reminder that even the most powerful and enduring phenomena in the cosmos are ultimately temporary, governed by forces we are only beginning to understand. The slow fade of a giant storm is a cosmic process spanning centuries, but the final act of a star like our own sun is a far more dramatic transformation. After billions of years of steady fusion, such a star exhausts its nuclear fuel and begins to die. Its outer layers are gently expelled into space, creating a beautiful, glowing planetary nebula. What remains is the star's exposed core, no longer generating energy, left to slowly cool for eons. This is a white dwarf. Though it contains a mass comparable to our Sun, all that matter is compressed into a sphere no larger than Earth. This results in a density so extreme it defies all common sense. If you could somehow scoop a single teaspoon of material from the heart of a white dwarf, that tiny amount would weigh more than an elephant here on Earth. The physics preventing this incredible object from collapsing further is a quantum phenomenon known as electron degeneracy pressure. In a normal star, the intense heat from fusion creates an outward pressure that balances the inward crush of gravity. In a white dwarf, that heat is gone. Gravity tries to compress the core into an ever smaller volume, but it is stopped by the fundamental rules of quantum mechanics. The electrons within the core are squeezed together, but they resist being forced into the same quantum state. This resistance creates a powerful, stable pressure that permanently halts the collapse, leaving behind a dense, Earth-sized cinder of stellar material. This object, a single spoonful of which would be unimaginably heavy, is the ultimate fate of our own Sun, a silent, diamond-like ember that will one day glow with only the leftover heat of its former life. Far beyond the known orbits of Neptune and Pluto, in the frigid darkness at the edge of our solar system, a ghost may be pulling the strings. The orbits of a cluster of small, icy worlds known as trans-Neptunian objects are behaving strangely. They are clustered together in a way that should not happen by random chance, their elongated paths tilted at similar angles as they swing around the Sun. This peculiar cosmic alignment points to a single, compelling explanation: the gravitational tug of an unseen giant. This is the hypothesis of Planet 9, a world thought to be up to 10 times the mass of Earth, tracing a vast, elliptical orbit so distant that a single trip around the Sun could take 20,000 years. Finding this phantom planet is one of astronomy's greatest modern quests. Scientists are not looking for a pinprick of light in a single image. They are engaged in a painstaking celestial detective story, using the most powerful telescopes on Earth to scan enormous swaths of the sky, searching for one faint, slow-moving dot against a backdrop of millions of stars. They are tracking its supposed gravitational signature, following the clues left in the wobbles of its smaller neighbors. The discovery of Planet 9 would be more than just adding a new world to our textbooks. It would be a fundamental rewrite of our solar system's story, revealing a hidden architect in its outermost reaches. It would prove that our cosmic backyard still holds colossal secrets, a giant lurking in the perpetual twilight, waiting to be found. Even as it pulls our tides, the Moon is in a slow, steady retreat from our world. The same gravitational dance that creates the ocean's rhythm is also pushing our celestial companion away, inch by inch, every single year. This cosmic drift is a direct result of the tidal forces between Earth and the Moon. Our planet's rotation is faster than the Moon's orbital speed, so the gravitational pull of the Moon creates a slight bulge in Earth's oceans. This bulge does not sit directly under the Moon, however. Earth's spin drags it just a little bit ahead. That forward-pulled bulge then exerts its own gravitational tug on the Moon, giving it a tiny push that adds energy to its orbit, causing it to spiral outward. This process is incredibly slow, a retreat of just under 4 centimeters annually. You could outpace it with a casual walk, yet this gentle drift has profound consequences over cosmic timescales. As the Moon moves further away, its gravitational grip on our world weakens. Our planet's rotation will gradually slow down, making our days grow longer. Billions of years from now, a day on Earth will not be 24 hours, but significantly more. The great tidal rhythms that have shaped our coastlines and guided life itself for eons will fade. The ocean's tides will become far weaker, a mere shadow of their former power. This slow-motion departure is a reminder that the cosmic relationships we take for permanent are merely moments in an epic, billion-year story of change. The same cosmic environment that preserves our footprints can also reshape life itself in unexpected and dangerous ways. On board the International Space Station, scientists have observed a startling phenomenon. Some common bacteria do not merely survive in microgravity, they thrive and become more potent. In one landmark experiment, cultures of Salmonella, the bacteria often responsible for food poisoning, were grown in the unique conditions of orbit. Researchers discovered that the spacefaring Salmonella was not just replicating, it had undergone a significant genetic transformation. The bacteria became almost 3 times more likely to cause disease when compared to identical cultures grown on Earth. This increased virulence is a direct response to the alien environment of spaceflight. In microgravity, the physical forces acting upon the bacterial cells change dramatically. The gentle pull of gravity, a constant presence on Earth, is absent. This shift in mechanical stress appears to trigger a cascade of genetic changes, altering how the bacteria functions at a fundamental level. The exact mechanism is like a master switch being flipped, activating genes that help the bacteria become more efficient invaders. For astronauts living in the confined, isolated environment of a spacecraft, this finding is more than a scientific curiosity, it is a serious health concern. A common illness that might mean a few uncomfortable days on Earth could become a mission-critical emergency in space, where medical resources are limited and evacuation is impossible. But this research also opens a remarkable window for science. By studying how bacteria adapt to the stress of space, we can uncover new details about their basic disease-causing mechanisms, insights that are often masked by the familiar forces of our home planet. The silent void, it seems, can make even the smallest forms of life speak in a more threatening voice. The silent void of space is not uniformly cold, but one particular nebula holds a record for a chill that almost defies physics. The Boomerang Nebula, a cloud of gas and dust located 5,000 light-years away, is officially the coldest natural place known in the entire universe. Within its expanding lobes, temperatures plummet to a staggering -272 degrees Celsius. This is a mere 1 degree above absolute zero, the theoretical point at which all atomic motion ceases. This profound cold is created by the nebula's central star, which is shedding its outer layers at a ferocious speed. The gas expands so rapidly that it cools in the same way your breath feels cold when you blow it out with pursed lips, a process called adiabatic cooling. This cosmic refrigerator operates on an unimaginable scale, chilling the nebula to a temperature even colder than the faint, uniform glow of the Big Bang that permeates all of space. Yet, in a stunning twist, the absolute coldest spot we have ever recorded is not in this distant nebula. It is right here on Earth, in a laboratory. Scientists using sophisticated laser cooling and magnetic trapping techniques have managed to cool atoms to within a fraction of a degree above absolute zero, creating pockets of matter that are even colder than the void between the stars. This means the ultimate limits of cold are not found in the vastness of space, but are being engineered by human curiosity, pushing the boundaries of what is possible and reminding us that the most extreme frontiers of physics can exist right in our own backyard. The quest for absolute cold reveals a universe of extremes, but the atmospheres of other worlds unleash a raw power that makes our own storms seem feeble by comparison. Even the most violent thunderstorm on Earth is dwarfed by the electrical fury found on our solar system's gas giants. Jupiter, a planet already defined by its eternal hurricane, also hosts lightning of an almost mythical scale. The Juno spacecraft, orbiting this giant, has detected radio signals from lightning strikes that are staggering in their intensity. These are not mere flashes in the clouds, they are superbolts, colossal discharges that can carry thousands of times more energy than the most powerful lightning strike ever recorded on our world. Imagine a single bolt of lightning containing more power than an entire terrestrial hurricane. This is the norm within the churning, turbulent atmosphere of Jupiter, where storm systems can be larger than our entire planet and persist for centuries. The same phenomenon occurs on Saturn, where the Cassini probe listened to the crackle of massive lightning storms raging across its cloud tops, but the strangeness does not stop with these familiar, though amplified, bolts. High above the thunderstorms of Earth, in the thin air of the upper atmosphere, a different kind of electrical magic occurs. These are not lightning strikes heading down, but vast, fleeting discharges that fire upwards towards the edge of space. Known as sprites, these phenomena are colossal jellyfish-shaped structures of glowing red light that flicker into existence for mere milliseconds. They can be dozens of miles across, connecting the tops of thunderstorms directly to the ionosphere in a silent, cosmic short circuit. Sprites, along with their cousins like blue jets and elves, are a reminder that our understanding of atmospheric electricity is still in its infancy. We live on a world where the sky can crackle with energy we are only beginning to comprehend, while other planets in our family scream with electrical storms of truly biblical proportions. Mars itself is home to a geological giant so vast it redefines the very idea of a mountain. Olympus Mons is not merely the tallest volcano on the red planet, it is the single largest volcano in our entire solar system. This is a shield volcano, a type built from successive flows of low-viscosity lava, creating a gently sloping profile that belies its staggering dimensions. It stands nearly 22 kilometers high from its base, a height that makes Mount Everest seem like a foothill by comparison. In fact, Olympus Mons is approximately 2.5 times taller than Everest. Its scale is not just vertical, but overwhelmingly horizontal. The volcano's base spans an incredible 600 kilometers in diameter. If you could place it over the country of France, its edges would brush against the borders. The caldera at its summit, the complex of collapsed craters, is so wide that you could fit entire cities inside it. This monumental structure exists because of a critical difference between Mars and Earth, the absence of plate tectonics. On our world, the crust is a fractured puzzle of tectonic plates that slowly drift over the molten mantle. When a volcanic hotspot pushes magma upward, it creates a chain of volcanoes, like the Hawaiian Islands, as the plate moves over the stationary heat source. But Mars is a one-plate planet. Its crust is a single, immobile lid. When a magma plume rose to the surface there, it remained fixed in one location, pumping out lava flow after lava flow for potentially billions of years, building a single, colossal mountain instead of a chain of smaller ones. Without shifting plates to carry it away from its source of magma, Olympus Mons just kept growing, becoming a permanent monument to the relentless, focused power of Mars's internal fire. The sheer scale of our solar system's greatest volcano shrinks into insignificance against the backdrop of the entire cosmos, a cosmos that challenges one of our most fundamental assumptions. We are conditioned to think that every explosion has an epicenter and every structure has a middle, but the universe itself has no center at all. This is perhaps one of the most mind-bending truths of modern cosmology, and to grasp it, we must think of the entire universe not as an object in a larger space, but as the entirety of space itself, expanding in all directions at once. A simple analogy can help make sense of this cosmic paradox. Picture a loaf of raisin bread as it bakes in the oven. The dough represents the fabric of space, and the raisins scattered throughout are the galaxies. As the loaf bakes, the entire body of dough expands uniformly. From the perspective of any single raisin, all the other raisins are moving away. A nearby raisin moves a short distance, while a raisin on the far side of the loaf moves a much greater distance. Crucially, no single raisin is the center of this expansion. Every raisin, no matter where it is located, would have the exact same view, seeing all other raisins receding from it. We are one of those raisins. When astronomers observe distant galaxies, they see almost all of them flying away from us, with the most distant ones receding the fastest. This does not mean we are in a special, central location. An observer in any other galaxy, in any other corner of the universe, would see the exact same thing, a universe expanding away from them in every direction. The center is not a place you can point to, because in a very real sense, the center is everywhere and nowhere all at once. Our cosmic neighborhood is filled with unexpected sensory details, including a smell that is anything but pleasant. The Rosetta spacecraft, which famously orbited and landed on Comet 67P, did more than just take pictures. It analyzed the very gases streaming off the icy body. As the comet approached the Sun, its frozen surface began to vaporize, creating a temporary atmosphere called a coma. The probe sampled this cloud and discovered a startling chemical cocktail. The unmistakable stench of rotten eggs came from hydrogen sulfide. The sharp, pungent odor associated with horse stables and urine was ammonia. Mixed in were the foul smells of formaldehyde and the bitter almond aroma of hydrogen cyanide, a highly toxic compound. If you could stand on the surface of that comet, you would be surrounded by an atmosphere that reeks like a combination of a barnyard, a rotten egg, and a toxic chemical lab. This bizarre olfactory profile is a direct window into the primordial ingredients of our solar system. Comets are ancient relics, icy time capsules that have preserved the original chemical building blocks from the cloud of gas and dust that formed our Sun and planets over 4.5 billion years ago. These unpleasant smells are the signature of that cosmic nursery. They are the raw, unprocessed materials from which worlds like our own were eventually constructed. Every time a comet swings through our inner solar system, it is essentially releasing the preserved scent of our own cosmic origins, a pungent reminder that the universe is not just a visual spectacle, but a place of profound and sometimes startling chemical reality. The universe's chemical signature is not limited to pungent gases, for we have found one of the most precious resources of all waiting in the eternal darkness. Deep inside the polar craters of both the Moon and Mercury, where sunlight has never reached, vast reservoirs of water ice lie frozen in the shadows. These are not shallow frosts, but significant deposits trapped for billions of years in a state of perfect preservation. The physics of this entrapment is a delicate cosmic balance. The Moon and Mercury have only the most tenuous atmospheres, called exospheres, which are utterly incapable of retaining heat. Inside craters at their poles, the Sun hangs perpetually below the rim, casting these basins into a cold so profound it approaches absolute zero. This creates a super cold trap, a natural deep freezer where any water vapor or ice that drifts in, perhaps delivered by comet impacts over the eons, becomes permanently locked. It touches the surface and simply stays, accumulating layer upon layer in the perpetual night. The discovery of this ice fundamentally changes our relationship with our closest celestial neighbors. Water is the oil of space exploration. It is not merely for drinking. When split into its component parts, hydrogen and oxygen, it becomes breathable air for astronauts and, most critically, rocket fuel. The energy required to launch a single liter of water from Earth's powerful gravity is astronomical. Finding this resource already in place, waiting on the Moon, transforms it from a distant destination into a potential interplanetary gas station. A lunar base could mine this ice, process it into fuel, and create a sustainable hub for voyages deeper into the solar system. Mercury, with its own hidden ice, presents an even more surprising possibility, a resource-rich outpost surprisingly close to the Sun's immense energy. This is not just a scientific curiosity. It is the key to unlocking a future where humanity is no longer tethered exclusively to Earth, but can use the materials left for us in the cold, dark places to become a truly spacefaring civilization. The same weightlessness that strengthens bacteria also reshapes the human body in a startlingly literal way. Without the constant, downward pull of gravity, an astronaut's spine begins to stretch. Here on Earth, gravity compresses the vertebrae, the stack of bones that forms your spinal column, squeezing the discs of cartilage between them. In the microgravity environment of orbit, that compressive force vanishes. Freed from this eternal squeeze, the spine elongates, the vertebrae gently drifting apart. This expansion can add up to 3% to a person's height. For an average individual, that translates to a temporary gain of about 2 inches. Imagine floating through your day, only to find you have outgrown your own body. This cosmic growth spurt, however, comes with a significant cost. The lengthening of the spine stretches the muscles and ligaments that support it, leading to a common and often painful condition known as space adaptation back pain. Many astronauts report a dull, persistent ache in their lower backs, a direct result of their bodies adjusting to this new, unloaded configuration. Scientists on the International Space Station have studied this phenomenon extensively, using ultrasound scans to observe the spines of crew members in real time. They have watched as the spinal column extends and the supporting muscles, no longer needed to fight gravity, begin to weaken and atrophy. This research is not merely academic. Understanding spinal fluid shifts and the associated pain is critical for planning the long-duration missions of the future, such as a voyage to Mars. A journey lasting many months in microgravity could leave explorers vulnerable to chronic pain and spinal injuries, especially upon their return to a world with relentless gravity. This temporary tallness is a powerful reminder that we are exquisitely adapted to our home planet's specific pull, and that venturing beyond it requires our very skeletons to change. Our galaxy is not a solitary island, but one of 2 great spirals locked in a slow, gravitational embrace. The Andromeda Galaxy, our largest galactic neighbor, is hurtling directly toward the Milky Way at an astonishing speed of 110 kilometers per second. This is not a chance encounter or a near miss. It is a collision course set in motion by the mutual pull of gravity across 2.5 million light-years of void. The merger has already begun in a cosmic sense, its finale scheduled for approximately 4.5 billion years from now. When this galactic dance begins in earnest, it will unfold over billions of years, a timescale so vast it dwarfs human history. Picture the first approach not as a violent head-on crash, but as a graceful gravitational pas de deux. The 2 galaxies will sweep past each other, their colossal gravity stretching out long, shimmering tidal tails of stars, gas, and dust pulled from their spiral arms. They will then swing back around, drawn together again, their momentum carrying them through a series of ever-tightening loops. During these close passes, the galaxies will be torn and twisted, their elegant spiral structures utterly disrupted into a chaotic, glowing maelstrom. Yet for any solar systems caught within this cosmic rearrangement, the experience would be strangely serene. The distances between stars are so immensely vast that the likelihood of 2 stars colliding is almost zero. From a hypothetical planet, the night sky would transform into a breathtaking, ever-changing canvas. A second, brilliant band of light would appear as the Andromeda Galaxy grew ever larger, eventually merging with our own Milky Way to fill the entire heavens with a continuous, dense tapestry of stars and glowing nebulae. After 1 billion years of this celestial turmoil, the 2 galaxies will finally settle, having merged into a single, massive, and likely elliptical galaxy that astronomers have nicknamed Milkdromeda. This new galactic giant will bear little resemblance to the 2 beautiful spirals that created it, a permanent monument to the slow, irresistible forces that continually reshape the universe. The ultimate fate of our galactic merger would be a chaotic dance of matter and energy, but nothing in the cosmos warps the stage of reality itself like a black hole. Its gravitational pull is so overwhelmingly powerful that it doesn't just trap matter, it warps the very fabric of spacetime, bending the path of light itself. This phenomenon, predicted by Einstein's theory of general relativity, is known as gravitational lensing. Imagine the smooth, taut fabric of spacetime as a giant, invisible rubber sheet. A massive object like a star creates a gentle dip in this sheet, but a black hole creates a bottomless well, a puncture so deep and steep that it twists the sheet into a funnel. Now picture a beam of light from a distant galaxy traveling across this warped sheet. Instead of moving in a straight line as we would expect, the light follows the curve of the distorted spacetime, bending around the black hole like a marble rolling around the rim of a funnel. From our perspective, this creates bizarre and beautiful cosmic illusions. The light from the background galaxy can be smeared into long, luminous arcs, or even duplicated, creating multiple ghostly images of the same single object arranged in a perfect ring around the invisible darkness of the black hole. This effect transforms the most light-devouring objects in the universe into nature's own telescopes. Astronomers actively use this principle to peer deeper into the cosmos than our own telescopes could ever manage alone. By studying how the light from incredibly distant, faint galaxies is magnified and distorted by a foreground black hole or even a massive galaxy cluster, we can see objects that would otherwise be far beyond our observational reach. Every distorted arc of light is a direct confirmation of Einstein's century-old vision, a visible testament to the fact that space is not a static stage, but a dynamic, malleable entity that can be stretched, twisted, and curved by the sheer weight of mass. The warped space around a black hole can reveal hidden galaxies, but some of the most profound secrets are not illuminated by any star at all. Drifting through the immense darkness between star systems are solitary worlds, planets that orbit no sun. These are rogue planets, cosmic orphans flung from their birthplaces by gravitational chaos. A young solar system is a violent nursery with giant planets jostling for position, their gravitational shoves capable of ejecting smaller, Earth-sized worlds entirely. Cast out from their stellar family, these planets are set adrift on an eternal journey through the freezing void of interstellar space. Detecting these starless nomads is one of astronomy's greatest challenges, since they emit no light of their own and are incredibly distant. Scientists rely on a clever trick of gravity called microlensing. Imagine a rogue planet drifting silently in the darkness, and far behind it, a distant star. As the planet passes in front of that background star from our viewpoint, its gravity acts like a tiny, fleeting lens. It bends and focuses the star's light, causing the star to temporarily brighten in a very specific way. This brightening is the only signature of the invisible world's presence, a ghostly footprint in the starlight that lasts for just hours or days before fading away forever. Current estimates suggest there could be billions, even trillions, of these lonely wanderers in our galaxy alone, far outnumbering the stars that anchor them. Picture the environment on such a world, a surface locked in perpetual night, its sun having set for the final time eons ago. Any atmosphere would likely have frozen solid, collapsing into icy deposits on the ground. The only heat would come from the planet's own radioactive core, creating perhaps a subsurface ocean trapped beneath a shell of ice, a dark abyss where the only light would be a faint, cold glow from the galaxy's stars, forever distant and unreachable. These solitary worlds redefine the very concept of a planet, proving that a world does not need a sun to exist, only the memory of one. That 8-minute journey of sunlight is a constant, silent reminder of our distance from the star that gives us life. The warm rays that touch your skin on a bright afternoon began their race across the void over 150 million kilometers away, a trip that takes precisely 8 minutes and 20 seconds at the universal speed limit. This is not a trivial delay. It is the fundamental lag time of our existence within the solar system. It means we are always looking at the sun as it was in the past, not as it is in this very moment. Every sunrise you have ever witnessed was actually the arrival of light that left the solar surface over 8 minutes prior. This fact holds a startling implication. a cosmic thought experiment that underscores our fragile connection. If the sun were to suddenly vanish, to be somehow whisked away at this instant, we on Earth would have absolutely no idea. For 8 minutes and 20 seconds, life would continue as normal. The sky would remain brilliantly blue, the warmth would still grace our skin, and gravity would continue to hold us in our familiar orbit around a point of nothingness. Only after that final, fateful delay would the sky plunge into an eternal star-studded night, the true signal of the catastrophe finally reaching us at the exact same speed as the light that once sustained us. This is the reality of our place in space. We are living in the sun's past, connected to our star by a thread of light that is never quite instantaneous, a gentle but powerful lesson in the finite speed of information in an infinite-seeming cosmos. Saturn's magnificent rings have long appeared as a timeless feature of our solar system, but their age holds a startling secret. Data gathered by the Cassini spacecraft during its final, daring orbits points to a cosmic reality far different from what we assumed. These iconic bands of ice and rock are not ancient relics from the planet's birth 4.5 billion years ago. Instead, the evidence suggests they are a recent addition, perhaps as young as 10 to 100 million years old. This means the rings formed when dinosaurs still walked the Earth, a mere blink in the deep time of the cosmos. Cassini's crucial measurements focused on the ring's mass and purity. The structure is far less massive than expected if it had endured for eons, and the ice is remarkably clean and bright, not yet darkened by the accumulated cosmic dust that would have steadily polluted it over billions of years. So if the rings are so young, where did they come from? The leading theory points to a violent and dramatic origin, the catastrophic destruction of a former moon. The small, icy moon may have strayed too close to Saturn, crossing the Roche limit, the point where a planet's gravitational tides become stronger than the moon's own gravity. This would have torn the moon apart, grinding it into countless fragments that were then shepherded by Saturn's gravity into the vast, flat disk we see today. Another possibility is the tidal shredding of a large comet that ventured too close. In either scenario, a celestial body was dismantled to create one of the most beautiful structures we can observe. This revelation transforms our understanding of Saturn from a static portrait to a dynamic system. We are not looking at a permanent feature, but a temporary, glittering monument to a fairly recent act of cosmic violence, a spectacle that appeared long after the age of the dinosaurs began and which may one day, over millions more years, slowly fade away. The same forces that sculpted Saturn's youthful rings also nurture a world of profound mystery within its orbit. Far from the brilliant disk of ice, the small, icy moon Enceladus holds a secret ocean. For years, it appeared as little more than a frozen, inert ball, but the Cassini spacecraft revealed something astonishing. Dramatic plumes of water vapor and ice crystals were seen erupting from massive fractures near its south pole, like giant geysers firing into space. This was not a dormant world, but one actively crying out into the void. Analysis of these plumes was a watershed moment. The particles were rich in salt, and Cassini's instruments detected the presence of simple organic molecules, the carbon-based building blocks of life. The only logical explanation for these continuous, powerful eruptions was a vast, global reservoir of liquid water hidden beneath the moon's icy crust, a subsurface ocean covering the entire world. This is not a small, isolated lake, but a deep, salty sea in contact with a rocky core, heated from within by the gravitational flexing of Saturn's immense pull. This combination of liquid water, organic chemistry, and a persistent energy source creates the three fundamental pillars required for life as we know it. Enceladus, a moon barely 300 miles wide, now stands as one of the most promising places in our entire solar system, to search for extraterrestrial biology. We do not need to land or drill. The moon is actively offering us samples of its hidden ocean, spraying its potential into the darkness for any passing spacecraft to collect. This tiny, active world forces us to reconsider where life could take hold, suggesting that habitable environments are not always on the surface of a planet, but can thrive in the warm, dark abysses of frozen moons, forever changing our definition of a living world. This cosmic web is the largest single structure we have ever identified, a pattern so immense it makes even galaxy clusters seem like tiny knots in its design. Picture the universe not as a simple collection of scattered islands, but as a colossal, three-dimensional spiderweb, with galaxies strung along shimmering filaments of dark matter that stretch for hundreds of millions of light years. These filaments intersect at dense nodes, where thousands of galaxies swarm together in massive clusters, but the true scale of this structure is defined by what is not there, the voids. Between these glowing strands exist vast, nearly empty deserts of space, cosmic bubbles so enormous that a single one can take hundreds of millions of years to cross even at the speed of light. This grand architecture is built by gravity acting on both the visible matter we see and the invisible dark matter that forms the skeleton of the cosmos. In the early universe, tiny fluctuations in density were amplified over billions of years. Gravity pulled matter toward these slightly denser regions, drawing gas and dark matter into the great filaments while emptying out the spaces in between. The galaxies we observe are simply the visible tracers, the glittering lights along this invisible cosmic highway. To truly grasp its size, consider the Sloan Great Wall, one of the largest known filaments, a conga line of galaxies over 1.3 billion light-years long. This is not a structure you can point a telescope at and see in one view. It is a map that only emerges from painstakingly charting the positions of millions of galaxies, revealing a blueprint for the universe on a scale that humbles all previous conceptions of size and structure. Every atom that constructs your body carries a cosmic origin story. The calcium in your bones, the iron coursing through your veins, and the oxygen filling your lungs were not born on this planet. They were forged in the heart of stars that lived and died long before our sun was even a glimmer in the cosmos. When the universe began with the Big Bang, it was overwhelmingly composed of the two lightest elements, hydrogen and helium. The rich diversity of elements that make up our world and our bodies simply did not exist. It took the immense gravity and searing heat of stellar cores to begin the process of cosmic alchemy. Inside a star, the crushing pressure forces hydrogen atoms to fuse together, creating helium and releasing the energy that makes the star shine. In massive stars, this process continues in a layered fusion factory, forging progressively heavier elements like carbon and oxygen in the core, while silicon and iron are created in the final, furious stages. But this process of creation has a limit. The formation of iron actually consumes energy instead of releasing it, and this is the star's death knell. With its energy source cut off, the star can no longer support its own immense weight, and its core collapses in a cataclysmic supernova explosion. The violence of this final act is so immense that it forges all the elements heavier than iron, from the gold in a wedding ring to the iodine essential for your thyroid. The explosion then blasts this newly created stardust out into the galaxy, seeding clouds of gas and dust that will one day collapse to form new stars, new planets, and eventually us. You are not just living in the universe is living in you. The very materials that allow you to think, to breathe, and to wonder about the cosmos are the recycled remnants of those ancient, giant stars. We are all, each and every one of us, a way for the universe to know itself, a collection of stardust that has momentarily coalesced into conscious form. From the silent, preserved footprints on the moon to the recycled stardust in your veins, this journey through 30 cosmic revelations has painted a universe of profound wonder and constant surprise. We have seen worlds made of diamond, wandered among phantom planets, and witnessed the slow fade of a giant storm that has raged for centuries. The cosmos is not a cold, empty void, but a vibrant and dynamic arena where the rules of our everyday experience are constantly rewritten. It is a place of breathtaking beauty and terrifying extremes, of eternal silence and unimaginable violence, all operating on a scale that both humbles and inspires. These facts are more than just trivia, they are windows into a reality far stranger and more magnificent than we often allow ourselves to imagine. They remind us that curiosity is our greatest compass, guiding us to ask the next question and to look ever deeper into the great unknown. Now we turn the discovery over to you. Of all these mind-bending truths, which one reshaped your perspective the most? Share your most astonishing fact in the comments below. We are truly curious to hear what captured your imagination. If this journey into the mysteries of space left you wanting more, be sure to subscribe. Our next adventure into the cosmos is already